Another example of a homogeneous function is we have this one, xy dx plus x squared plus y squared dy, wherein the degree of each term is equivalent to 2. For this one, the degree is 2. The degree for this y equals 2. And then for this part, the degree is 2. So this is a homogeneous function. Now again, in a homogeneous function, we will make use of our substitution. Let x equals, we have to determine first which of the following terms is simpler. So if you have noticed this one, and then this one, this is simpler compared to this group. So this is dx. Therefore, we let x is equivalent to vy. So we will make use of this substitution because this part is simpler compared to this part. So let x equals vy. And then dx, the derivative of x equals the derivative of vy. So you have here v dy plus y dv. So again, this is the derivative of uv. This time, we will substitute all values of x as vy and dx as v dy plus y dv. So we will now start substituting the value of x here. So instead of writing x, we will have vy. Okay, so we have vy and then y, and then our dx is v dy plus y dv. Y dv, okay, plus, instead of writing x, we will substitute as vy. So this is raised to 2, so v squared y squared. V squared y squared plus y squared, and then we have dy that is equivalent to 0. So this time we will combine this one, v squared y squared dy. So we have v squared y squared dy, and then v times y squared times y, that is vy cubed dv plus vy cubed dv plus this one is v squared y squared y squared, and also we have dy. We will distribute dy and plus y squared dy equals 0. So we will group all dy's and dx. So we have here 3dy. So dy, and then we also have dy. So we have 3 dy's. So if we combine this one, we have 2v squared y squared, 2v squared y squared. Okay, you have 2v squared y squared, and then plus y squared dy. And then we have this one as v plus, okay, sorry, plus v y cube dv, which is equivalent to 0. Okay, for this part we will factor y squared. So y squared, 2b squared plus 1. Okay, I will write here y squared, and then you have here 2v squared plus 1. We will factor y squared. So what remains here is 2b squared plus 1. That is your dy, and then plus v y cube dv is equivalent to 0. Now, of course, by rearranging this one, the result will be by cross multiplication. So y squared, this is y cubed, so that becomes dy over y. You have here y squared, y cubed, so you will cancel y squared and y cubed. What remains here is y, therefore dy over y. Okay, this is dy over y. And then for this part, you have here v dv and then over 2b squared plus 1. So we have plus v dv over 2b squared plus 1. Okay, that is equivalent to 0. And then this time we apply integration to both sides. Now this one is ln u, du over u. Also, this one, we can make use of du over u. Our u here, for this case, our u is, let's say, our u, for this case, I will write here our u equals 2v squared plus 1 du equals 4v plus, 4v dv. So this is v dv, this is 4v dv. Okay, 4v dv. So you have here, you must have 1/4 as your multiplier. So when we integrate dy over y, that is equivalent to ln of y plus, you have here your 4, so you have 1 over 4 ln of 2b squared plus 1, which is also equivalent to, we will write here ln of c. Now, if you have noticed, we have here 4. This is a fraction, so we will multiply both sides by 4. So this becomes 4 ln of y plus, for this part, you have here ln of 2v squared plus 1. And then we have 4 ln c. And then make 4 as your exponent to y. Okay, so I will write here a line so that when we combine this one, you have here ln of y raised to 4. This 4 will be your exponent to y, and then this is positive, so you have to multiply this one. You have ln of 2v squared plus 1, okay, equals ln of c raised to 4. So we will cancel ln to both sides. So what remains here is your y to the fourth times 2v squared plus 1 is equivalent to c raised to 4. This time, we will substitute b from our substitution x equals by. Remember, x equals by. So, v is equivalent to x over y. So, substitute the value of v as x over y. So, we have y to the fourth times 2. And then instead of writing b, we have x over y squared. X squared over y squared plus 1 equals c raised to 4. And then combine this one with 1. Okay, so we have y to the fourth times 2. Okay, so I will write here as 2x to the fourth, square, 2x squared plus y squared all over y squared equals c to the fourth. So we can cancel y to the fourth, y squared. So that becomes y squared. And then we have here 2x squared plus y squared, which is equivalent to c raised to 4. Okay, so if you have noticed, okay, I will rewrite our final answer here. We have y squared on this portion, y squared times 2x squared plus y squared, that is equivalent to c raised to 4. So this will be our final answer.